We present Outcome Explorer, a causality-guided interactive visual interface for interpretable algorithmic decision-making. We first demonstrate how an expert user such as a machine learning researcher can use Outcome Explorer to build and interpret a causal model. Suppose, Adam is a male research engineer at a technological company. Adam wants to build a causal model for predicting housing prices using Outcome Explorer. He starts off Outcome Explorer by uploading the housing dataset on the interface. He has prior knowledge about the dataset but is unsure about the underlying causal structure. He decides to use automated algorithms to search for causal structure. He selects the PC algorithm for searching the causal structure. Upon seeing the causal DAG obtained from the PC algorithm, Adam uses prior knowledge to refine the causal relations. For example, Adam notices that the initial model has an undirected edge between industrialization and distance from city. To use structural equation modeling, Adam needs to create a directed acyclic graph. From domain expertise, Adam knows that distance from city can be a cause of industrialization, but the opposite relation is not plausible. Adam directs the edge from distance from city to industrialization and evaluates the model fit and the prediction accuracy of the model. On the top right corner, Adam can see the model fit measures such as CFI, RMSEA, BIC score. Below that, one can observe the parameter estimation for each edge. And on the right bottom corner, Adam observes prediction accuracy for the model. Adam further notices that the variable zone does not impact the outcome variable. Keeping this variable in the model will incur more regression errors. He removes the edge and notices that all the model fit measures were improved. The prediction statistics did not change since zone did not impact the outcome variable. Satisfied by the prediction accuracy of the model, Adam hits the Save Model button and moves on to the Model Interpretation module. After creating the model, Adam wants to explore and verify the model before making it public. In this module, the user can see a left to the right representation of the causal model. Adam starts off the exploration process by selecting a sample data row. He observes that the selected row is immediately reflected in the feature values and the outcome of the model has changed. He also observes that the edges entering the endogenous variables became blurred, deactivated. This is to indicate that the variables were set externally and can no longer be estimated from its parents. For example, Adam notices room per dwelling can no longer affect the lower status population. But, it can be activated by cancelling intervention on lower status population. Adam notices that the selected housing has a relatively small price. He decides to compare the selected housing with a housing with higher price. To do so, he selects a data point with higher housing price from the profile map. Immediately, an orange profile is created in the causal DAG. From the two profiles, Adam easily understood where the two housing differed and how that affected the outcome. At this point, Adam hits the Save Profile button to save both the profiles in the tracker. Adam now changes values in the knobs to observe their effect on the outcome. We now describe how a non-expert user can benefit from our tool. Suppose, Emily is a middle-aged female who is aiming to purchase a new house. Emily came to know about a web service which lets the user explore different neighborhoods and estimate prices of houses in the neighborhoods. Emily decides to use the service to understand the quality of a neighborhood. She visits the site and starts off by making sense of the variables and how they are connected to each other. After understanding the causal relations between variables, she now starts putting values to the knobs in the interface. She observes that once the value of her internal node is set, edges leading to that node become blurred. For example, Emily sets the value of lower status population, which decreased the median price of the houses, but also blurred edges entering lower status population. Intuitively, she understood once I know the exact value of lower status population, there is no need to estimate it. Similar way, Emily changes other input features. While changing the input features, she notices some configurations are very rare according to the realism meter. Suppose, Emily found the perfect housing, but the price is high. Emily wants to take the price down with minimum changes in this input configuration. To do so, Emily clicks the Initialize Comparison button. Immediately, a new orange profile is created in the interface which is exactly the same as the current green profile. Keeping the green profile constant, Emily iteratively changes the variables to ask what-if questions. She confirms that the orange line stays on the right end of the meter, which means that these configurations are very common. She also confirms the orange disk in the profile map stays close to the green disk, ensuring minimal changes from the ideal housing.